the first one is basically do some reading. Like this top part is around getting yourself the basic education of how does Docker work? What is basic security in Docker? How does Docker even, protect your container, that sort of stuff. And I have basically a production talk you can watch here. We're not going to watch that now, but I do have a link here to the Docker security guide. Now, what's interesting about the Docker security guide here is that it's really just about how does Docker security work, or how does Docker itself work. And there's way better videos in my course. I put links in there to other reference videos that are an entire hour about the underpinnings of Docker. But the two main things you need to care about are kernel namespaces and cgroups. And namespaces, they go through a nice overview of how this stuff works. The summary here is there's two main features in Linux that allow Docker to even be possible. Kernel namespaces is a way for the kernel to take an application or a set of applications and namespace them. Namespace is essentially limiting their view, their access to any resources or what they see, whether that's networking, other programs in memory, or files on disk. It limits that scope per program. And so it can be for each individual program, and we know those as containers now, because namespaces isn't specific to Docker. It was around a lot longer than Docker has been. It's been actually around as a concept in different Unix distributions for over a decade. We might have heard this in Solaris jails or other types of technologies that essentially made you think that you were on your own server, but really you were contained inside a server with many other people and many other apps, right? We've done that a lot in Linux and hosting platforms. So namespaces is that feature. It gives your container its own NIC. It's a virtual NIC just for that container. And it gives it its own file space where it doesn't see the rest of the file system, and it doesn't let it see other programs running outside of that container. So it's about its access and view, right? That's namespaces. And that just works out of the box. That's how Docker makes a container run without seeing everything else on the system. The other big thing is control groups, or we call them cgroups for short. And control groups are mostly about limiting resource usage. So you can tell a container it only has access to 1 gig of RAM, 1 CPU, that sort of stuff. It also allows for some metrics where you can measure things around that stuff, but it's really mostly about limiting your container. Now, remember, your containers by default can have access to all resources in terms of they can eat up all the file space, they can take all the CPUs, and they can eat up all the memory. That's just a standard container, but you can set options in Docker Run or in Swarm or Kubernetes. Any of those things have the ability for you to control resources. So, but it's just not by default, right? By default, any container gets everything. So when you're going into production, this is definitely on your to-do list. I wouldn't say control groups are necessarily a security feature, except for a particular application taking up everything that it shouldn't, and then it makes other things not be able to run, right? So that's not, I don't look at that as direct security. I look at that as sort of semi-related to security, where someone could technically do a denial of service by letting your app eat up all the resources on your server. So, that kind of thing. So those are the basics. Once you understand the basics, there's a couple of good blog articles here on different types of security tools out there. And there's tons of tools, right? I'm not going to mention all of them today. Obviously, there's lots of stuff out there. But a lot of them are complicated and take projects. You have to implement them or buy them and then dedicate servers for them, right? Big products around auditing or making sure you pass certain credentials like a PCI credit card security or government regulation security, that kind of stuff. All right, first up is just running in Docker. And this requires you to sort of create an argument, because this is probably, if you're having a barrier with this, right, just using Docker, number one, if you can't get this done, well, one, you're probably not watching my show. But that probably means you have a security team or management that has read something somewhere that there's, security around Docker. The latest thing was, if you scroll down to the bottom of this issue, is that there are images out there now, and it's not news to anyone that if you run random software off the internet without checking it first, you may end up with a virus. And basically, people are creating images on Docker Hub with cryptocurrency or cryptojacking tools inside them that will essentially run, you think you're running this other piece of software, but you're really running something nefarious for the hackers. Well, this is not new, and Docker doesn't necessarily make this any easier than anything else. We all know the rules. Don't run random images, just like you wouldn't run random code on your server. You don't download random stuff, from the internet. So don't do that in images. Only run official images or those that you absolutely trust, meaning the vendor's staking their relationship with you on that image, and you don't necessarily have to scan the image with every line of code, but you're using reputable products from reputable companies, right? So if you're doing that, this whole recent news thing that made a bunch of headlines doesn't even matter. Like it wasn't a vulnerability in Docker. It was people configuring Docker by disabling security that was in and out of the box, and then going and downloading random software and images. So of course they're going to have problems, right? I think the real news there is that hackers are getting more sophisticated. They know more of us are running containers, so they will start putting viruses in container images, right? And Docker Hub does not scan every image. It only scans for security issues in official images. It's not a feature of Docker Hub anymore. Well, they never did it for everyone because there's 30 million images, but you could pay them in the past. And you can't pay them anymore for that. All right. So step one is just using Docker. In case you didn't know, when you use Docker out of the box, it is already hardening the application in there. One, that application can't see the rest of what's running on the system. So it can't even access the rest of the stuff running. It's just only what's in that container, right? The real big thing there, though, is that a container in Docker enables a bunch of Linux security features that normally, if you just run apps on the host, aren't enabled by default. And that includes seccomp, AppArmor, SE Linux, and kernel capabilities. So those 4 things are all inside of Docker and enabled by default, assuming your host supports them, because not every Linux distribution supports every security tool. But those 4 things, especially AppArmor, seccomp, and Linux capabilities, are enabled out of the box for every container you run, which is why sometimes certain applications, you have to run it like -- privilege. You kind of have to run it with the privilege mode. That's because those defaults are conflicting with whatever that app wants to do, because those defaults that Docker sets are common for most applications to work correctly. And so Docker basically went through a whole bunch of tools way back in the day, scanned a whole bunch of common open source software, and figured out what they all tend to have in common in terms of rights, in terms of permissions on the host. And they took the rest of them, hundreds of other things that the regular applications can have access to, and they took them away. And that resulted in Docker having a very secure default profile. So if you just run Nginx on a host, it has access to everything in the kernel that user has access to, which is usually most of everything. But if you run it in a container, it locks so much of that down that it's automatically more secure out of the box, even if you didn't customize any of those things. So that's my argument for why Docker for security. Just do it, and you automatically get all these things enabled. Most people don't know about how to use AppArmor or how to use seccomp or SE Linux, how to customize those things for each application. But Docker did, and that's what they do out of the box. Number 2, scan your host for proper Docker config. So here's a really great tool, free, called Docker Bench. Made by Docker, this tool will scan your host. Basically, you run it on the host that has Docker installed. And the output kind of looks like this. It'll give you blues, greens, yellows, reds, all that stuff. And it's a configuration checker. It's not scanning for viruses or vulnerabilities or anything like that. It's scanning your configuration. Did Docker get installed properly? Does Docker have all the right permissions that it needs? Does it have all the right kernel capabilities to perform proper functionality, especially around security? So, for example, if your system doesn't have SE Linux enabled or AppArmor enabled or installed, and Docker wants to use those things, it will note that stuff here. And so before I decide on a proper configuration for servers that are going to go even just for testing, not just production, I'll just run this little shell script. And you can run it straight from the website. They give you instructions here on how to run it. And it'll dump out a bunch of stuff. Now, it's never going to all be green like most security tools. It's still going to give you certain things, and you have to look through those and decide, is that okay? And it just kind of makes you a smarter admin, makes you aware of certain limitations or problems with your system. And you might find out that for a certain Linux distribution, that's not going to work at all. Like that particular thing is just going to have to be insecure or not a feature, that kind of stuff, right? So it's good education, and it uses a thing called the CIS Docker benchmark, which is sort of a industry standard for how to make sure the security of a host is properly set up for Docker. And it's great. It's an easy utility to run. I would run it, like if you're going to be building servers with Ansible or Puppet or whatever you're using to build servers, you would, once you've got that configuration, I would deploy your servers into a mock setup, running your configuration tool. And then I would run Docker Bench against it. And you would get a bunch of output, and you could go through those one by one, deciding, am I okay with this? Can I fix it? What do I got to do? Should I ignore it? That kind of stuff. Next one up. This is a big one. Don't run your apps as root in the container if you can avoid it. And if I do this real quick on a little demo here. All right, so I've got Docker running. At least I should. All right, and if I just run, if I just run Nginx, right, and I do a Docker top on that container, what do we see here? Inside the container, Nginx started a process at root, and then it created a new process as a non-root user. See how that user is 101? So this is common of a lot of daemon-based programs like MySQL, Postgres, Nginx. A lot of them that aren't programming languages will automatically do this. So this is safe. What this is doing is this is allowing Nginx to spawn off worker processes that don't run as root to do the majority of the work. So they have one master process that runs as root, but that's not what's accepting connections and doing majority of the work. Most of that's in these worker processes, and they run as a normal user, which means if there is a vulnerability in Nginx, chances are when incoming connections are coming in and someone's trying to exploit the Nginx HTTP protocol, it's going to be locked or jailed into this user at most of the time, unless there's a serious vulnerability that's up here. So down here, and then they're limited to what they can do, right? Even if they were to take over that process somehow, they're still limited as the user. So this is okay. This is still not running as true root inside the container. What I really am talking about is if you were to run a Python app or a Node app or something like that where it's a programming language, then that's going to be something that defaults to root, because the programming language in the container doesn't know how your program works. It doesn't know what you want it to do. So it's going to do root by default. And that's more about application compatibility. We might say that we want this to be secure by default, but Docker chose for all these official containers to really run as root for the programming languages. So let's go check that out. Oops, not that one. Firefox. So if we go, let's say, over to Hub, and let's just do Node. This is common of most languages, but I'm just going to pick Node as an example. So inside Node, if I go into one of the Docker files here, then I search for user, you'll notice that I don't actually find anything. It's only this user add here. But you'll notice that it does this, right? It's technically adding a group called Node, and it's adding a user called Node. But if you search the rest of this file, you realize that it never changes to that user with the stanza user, right? It doesn't. You should see user Node in there somewhere as a line. They don't do that because that's your job. So what you should be doing in your down level Docker file, so any Docker file you're creating off of these official images for programming languages, you should be taking advantage of the users they're creating for you. And if they're not creating those users, you can create one yourself the same way. You can just steal this little 2-line thing and change to whatever the user you want it to be. If it's for Python, you might just call it Python user, whatever. So if you're doing that, then the applications you run will not run as root in the container. By default, if you just run any standard Node app, it will use the root user in a container. Now, why is this so important? Well, 2 things. One, if someone is able to break through your application and hack into your application and gain access to the file system, if that application is root, then in the container, they can do whatever they want in the container, right? They can write files to the file system, they can install more programs in that container, they can run whatever they want in that container. So we really don't want them to do that. We'd rather them be very limited. So if your applications support it, do this. You basically make sure that you have the user available. And then I have an example from DockerCon over here. At DockerCon, I had a whole talk on Node.js, and one of the topics was on the user. So let me see if I can find that. All right, see what I did here? This is a pretty simple file. I'm gonna link this and put it in this Docker file. So in this Docker file, I didn't create a user because the node image already created it for me. I'm just changing the user to user node. And then I'm installing my packages with these 2 lines, and then later I'm going to run it. Now you'll notice that I have to start using the chown option in my copy commands to make sure that my files are now the same user as the user my program will run as, or otherwise there could be problems, right? My application probably, if it can't read the files, then it can't run it, right? So I need to change those permissions, and I can do that with a 1-liner on a copy command. You'll also see up here that I'm creating the directory and chowning it as well, so that whenever the app is copied in, I just want to make sure, extra sure that the permissions are there so that it can write. Because the minute I change this user, then this copy command, or specifically this run command, will run as that user. And if it doesn't have permissions to write to the directories, then it's also going to fail. So the reason that Docker doesn't do this for you is because they know that your things will probably break. So you need to take these extra steps, but it's not that hard. It's really not. You can probably do all of this testing in a day, and then you'll want to run your systems, through full CI and full testing on your servers, because sometimes, and PHP is one of the ones that's bad at this, PHP likes to run a bunch of log files and do a bunch of writing to disk. Really anything that's allowing user uploads will write to disk. And so you got to make sure those permissions are correct so that when people are writing files, like let's say they're running a WordPress blog, that WordPress blog will be writing to disk when users upload images into their blog. And you want to make sure those permissions are going to work. So you're going to have to definitely do some testing. But once you've done that, now your application will not run as root. So it can't have full control in the container. The other reason you want to do this is if there's a vulnerability in Linux, which is rare, or Docker, which is also very rare, then there's less likelihood that they're going to break out of this container. And that's only happened, one time that I'm very aware of, and I actually documented a little bit of it down here. Dirty Cow. Dirty Cow was a vulnerability in Linux that allowed you to get out of a container, right? And the changing of your user right here wouldn't necessarily solve the entire problem, but it certainly didn't hurt that problem. Other vulnerabilities it would probably protect against. But this is a best practice. I think that if you have a security team, they're kind of going to insist that you don't run things as root. So you would do that.